Alrighty, day 20, let's get it. With your help, the elves managed to find the right parts and fix all the machines. Now they just need to send the command to boot up the machines and get the final sand flowing. The machines are far apart and wired together with long cables. The cables don't connect to the machines directly, but rather are communication modules attached to the machines that perform various initialization tasks and also act as communication relays. Modules communicate using pulses. Each pulse is either a high pulse or a low pulse. Bits, when a module sends a pulse, it sends that type of pulse to each module in its list of destination modules. There are several different types of modules. Flip-flop modules are either on or off. They initialize off. If a flip-flop module receives a high pulse, it is ignored and nothing happens. However, if a flip-flop module receives a low pulse, it flips between on and off. If it was off, it turns on and sends a high pulse. If it was on and turns off, it sends a low pulse. Conjunction modules. Remember the type of the most recent pulse received from each of their connected input modules. They initially default to remembering a low pulse for each input. When a pulse is received, the conjunction module first updates its memory for that input. Then if it remembers high pulses for all inputs, it sends a low pulse, otherwise it sends a high pulse. There is a single broadcast module named Broadcaster. When it receives a pulse, it sends the same pulse to all of the destination modules. Here at Desert Machine headquarters, there is a module with a single button on it called aptly the button module. When you push the button, a single low pulse is sent directly to the broadcast module. After pushing the button, you must wait until all pulses have been delivered and fully handled before pushing again. Never push the button if modules are still processing pulses. Pulses are always processed in the order they are sent, so if a pulse is sent to modules A, B, and C, then the module A processes pulse and sends more pulses, then pulse is sent to module B, and then C would have to be handled first. Then module A processes its own pulses and sends more, then pulse is sent to module B and C would have to... Okay, and this module configuration of broadcaster is 3.k. The following pulses are sent: button low to broadcaster, broadcaster low to A, to B to C. Okay, okay. We're gonna... Yeah. I get the gist of what this is trying to do. So we're just gonna do a good old input map split, sorry. Split map. What do you do for each line? I guess we're gonna go and split split parts. Line split on this. And I guess actually I can do the whole thing, that way it removes all the spaces. And then map each part. No. So I guess this is going to be const module. Const module type is going to equal and broadcast is only one. So this is just going to be parts 0 substring 01. If I can spell const correctly. And then the module is going to be part 0 1 on. Actually, it's going to be module type. If it's B, it's going to be 0. Otherwise, it's 1. Just because the broadcast module will always have its own. Okay, so there's the module, and then destinations is parts 1 I'm gonna call it trim just to be sure. Actually, you know what? We're gonna not do that yet. We're gonna do split on this, and then map it to d.trim. Okay, this is a module. There's our destinations. Let's call reduce, and this is going to be modules. Start as that. Const module. That's gonna be a type. Make life easier. Actually, we'll call it like that. So that way I can do key string into name. None of the names gonna be needed there, but we'll do type. And then we'll do dest. Just gonna be a string array. Okay, and then it's gonna return modules, and we're gonna go ahead and do module name is module, type is module type, and dest is dest. Okay, so now we have modules. So what we're gonna need to do is, okay. Yeah, in the first example, the same thing happened. Okay, so this complete cycle, A turns off, causing con to only remember. To get the cables one with the elves to push the button 1,000 times, how many pulses get sent as a result? Okay. Okay. So for array from length 1,000 map it's actually for each reduce, yeah, and pulses, that's all we need. Start at 0, and here is part 1. So just so it's happy. Okay, so we have pulses. So now what we need to do is actually pulse these modules. So we need to do const broadcast is going to equal modules, and it's just broadcast, right? Broadcaster. We start with that. So when you push the button, it sends a low pulse, right? Button sends a low pulse, and then the broadcaster just sends it all to whatever. Okay. And then okay, so we're gonna need a const send pulse, which is gonna equal module send pulse 2, and then high with a boolean. And this is going to return a number. So what's going to happen is we're going to turn pulses plus send pulse 2. This is going to be recursive call, pass in broadcaster and false, because that's what this sends. Okay, so it's going to pull out. This is going to be the module. Module name. Okay, and so what we're going to do is if module type. Actually, we'll do B first. B is easy enough because it's broadcast, so we can just do that. We need to do sum there, entire file. And we can do sum plus equals. Actually, we can just return, because it's only this one pulse. We can return module destination reduce m module sum m. It's actually the destination. And it's actually just going to be sum plus this. So I need to dest. And it just broadcasts a low, right? Yeah, it's just going to broadcast high. 0. Sweet. So the next one is going to be that. What is the flip-flop? On and off. They're initially off. So I guess he's going to need a state. Is high. I think they both initialized off. Yeah. Okay. Okay, so if we have the flip-flop, so the on and off, initially off, receives a high pulse, is ignored, and nothing happens. So if high, if not high, if it receives, nothing happens. It receives a low pulse that flips between on and off. So if it receives high, module dot is high equals that. That goes away. So it's not the opposite. If it was off, it turns on and sends a high pulse. If it was on and turns off, it says low pulse. Okay, and then we just go to all of the destinations and we send this. Easy enough. Otherwise return 0. Conjunction is this, else if is that. Remember the type of the most recent pulse received from each of their connected. Okay. Okay. It's going to become that is high 0. Remembers the type of most from each of their connected input modules. It initially defaults to remembering a low pulse for each input. When a pulse is received, the conjunction module first updates memory for that input. Then, if it remembers the high pulses for all inputs. So, conjunction ones need to know. Okay, so we're not done yet. Modules. Okay, so I need to go through this. So I need to go object.keys for modules for each module. If module dot, or if modules module type is, and what we need to do is keys filter key dot dest includes module. So oh, okay, so this ain't gonna work. All right. Module, I need subtypes. This is not how I want to be doing this. This is gonna be broadcaster module. Note is high. And so we're just gonna stack these types like this. Flip flop module. Flip-flop module, and then lastly it's what a conjunction module. And so is high is actually going to be it's gonna be input key. That's the wrong thing. There we go. Input string, not key. Okay. Okay, so now we need to do this little ladder in here instead. I'm gonna do this to make my life a bit easier. Okay, so now if module type is B, it's gonna just be that. Module type is this. Then we also need to do is high, is false. And then lastly, this one is high, is that. Okay, there's that solved. This is gonna be inputs cool module as flip-flop module. I'm lazy. I'm not lazy, I just want to keep typing this out like this. Flip-flop module and then conjunction module. Okay. Okay. So now there's the inputs, and so what we need to do is then do modules as conjunction module dot is high is going to equal inputs reduce call it out, I guess, inputs, and it's just going to be out with the next key. Nope, with the next key being input false. Holy, all right. We should be good now. So now when we get to here, we get conjunction module is high. We need from. And then from is button. Don't think it matters, but okay, is high. This is from equals high, and then we need to see is if it's all high. Okay, so then if object keys is high, filter CM is high, key if they are all high, which I want the opposite of, then we go ahead and do this. Oh, it's in the low. Oh. Okay. It does this anyways. But it sends a low. It sends a low pulse that remembers all high. So if length is not equal to 0, that means if yes. Okay. We should be good, I think. I hope. Let's see how this goes. Module.type. We have a type that's not there. Console log. How did that happen? Is there no RX? Oh, is RX out? So there's RX, but there is no RX. So I guess it's just nothing? Okay. If module return 0. Simple enough, I guess. And we get 0. That'd be because we aren't adding 1 for... actually, it should be adding... or these could just default to 1. No, well, they could be defaulting to the length. That's what they're starting as. Okay, now what do we get? I get that number. Is that my answer? Nope. Alrighty, alrighty. Test input time. Oh wait, that'd be because I didn't even do this correctly. But you can multiply the total number of low pulses sent by the total number of high pulses sent. Oh. Oh. We need to return that. So it's low and high, so okay, and then it's gonna be alright, I'm gonna make this a bit easier. Const pulses sent return sum 0 plus pulses sent 0 and this 1 and 1. And I gotta update all of these. And grab that. Okay. Return that. Initialize to that. And we're sending const send high. All right. And so this is also going to be 0, 0. And this is going to be const sent. And we're going to return pulses, pulses, sent, sent, sent. And then it said multiply them together. So part 1, 0 times part 1, 1. No, okay. Alright, still back to the test input. The broadcaster button low Is it because I didn't account for the one by the button? That all? I just didn't account for the one low pulse from the button. I didn't count with the button. Nice. Alright, that's not too bad. Now how is this going to fail? Whatever. The final machine responsible for moving the sand down the island has been... Oh, there's RX. The machine turns on a single low pulse to send to RX. Reset all modules to default state, waiting for all pulses to be fully handled after each button press. Was the fewest number of button presses required to deliver a single low pulse to the module named RX? Okay. So... Alright. Okay, so we have modules, so we need to reset. Okay. Const, is it? One pulse 2. So all that's messed up is this. So const get modules. Goes here, and then all this does is return modules. The easiest way to do this. And then this needs to take in modules. Const part 1 modules. Okay. So what's going to happen is for part 2, it's the exact same thing. Part 2 modules, part 2, but this is going to be instead be while part 2 modules are X. To deliver a single low pulse to the module named RX. What is RX? It doesn't actually say what RX is. I want this. Let's just do it here. So if module name equals RX and not high. Let's just do that. And then, oh, these all need to pass modules through, right? Modules. Okay. Fine. So before we run part 2, set RX low to false just so it correctly is reset, and then while This is not like that. Go ahead. And send pulses. And we do need to do let count presses, sure. While that presses plus plus. And then at the very end, we should just be able to output presses. And in theory, this might take some time. I don't know. I'm just going to call it there. I don't know. I'm close. It's just I don't know how to figure out the cycle. I don't know how to figure out this. So I don't know. I'm gonna call it there. I'm close. I don't know. I don't know. So at any rate, there you go. There's day 20. It's not too hard. You're just giving us inputs. Just figuring out. Part 1's pretty straightforward. You just send them through. I use recursive for the pulsing. So when it pulses, it goes to each module. It pulses that module, and then recursively calls its individual bits. Yeah. Actually, I'm thinking about this now. This might be incorrect, but it worked. I don't know if I got lucky, because I'm realizing now that because I did recursively, I wasn't correctly respecting what it said of how this works. So don't even take mine, and mine's wrong. Mine does not follow this. Mine definitely does recursive, so it goes to A and then does A, and then yeah, that's not how it's supposed to work. But that's how I did it, and it somehow worked. So never mind. Don't even test my answer. Yeah, there you go. Day 20. Thanks for watching. I hope you guys enjoyed. See you guys tomorrow for day 21. Okay, so I've actually decided I'm going to fix this because this seems wrong to do this code and it be right but wrong. So we're gonna go through and fix this code to be actually what it should be, which is not going to be recursive, but it's going to be kind of like a breadth-first search. So we're going to need is const. This is going to be our modules to run. And what we're gonna need is all of this data. So it's actually gonna be a list of these. And we're gonna initialize it with broadcaster. We're gonna initialize it with this data. From button high being false. So what we're gonna do is not this. Wrong part for right now. Part 1 we're gonna do is this. This actually goes inside here, and we're gonna do while modules to run dot length is greater than 0. I'm gonna do to run equals modules to run pop. Not shift. Yeah, shift. So there's our to run. And instead of send pulses, this can still be this. Send pulses. Call it calc pulse or yeah, that's fine. No, we're gonna move this out of here. Nope, nope, never mind. Or can we reuse this to do this? Because probably gonna need this anyways. This here. That. I'll just run. There's the module. There's to run, so it's not module name. To run to module name. Continue. I'm gonna do this just so I can see what's all messed up. To run that from H. This is to run dot high. Okay, and so what we do here is instead of doing this, we need to do push, and we're gonna push onto it this. So module name being dest, from being this, and high, which is good. OHH. Cool. And we don't need to worry about this. So we can actually just do a straight up for each now on these. Make life a little bit easier. That goes away, and then we do need our count. We need let pulses 0, 0. I do actually need to copy this. So we push, so we're gonna have to do is pulses 0 plus equals pulses 1 equals that. H, not high. And so that's what this is going to be now. So this will correctly do it. It's not going to be, it's going to be, like I said, bred for a search instead. No, this should actually be to run high. Okay, and then here's this bit again. Don't do that, dest, and then high is actually going to be that. Which means here is low, here is high. And that is taken care of. Lastly, this one, same thing. Send high, dest, module name, good. And here is this logic. That goes away. Oh, I forgot that. This goes away, and now this is correct. And we return pulses at the very end. So now part 1 is just this. Wait, no, that's still right though. This still stays the same. And I'm gonna comment out part 2 for right now. And hopefully part 1's gonna give us our same answer. These are actually in the wrong spot. These actually go outside here. Because, yeah. A bunch of zeros, nice. How do I keep getting zeros? Guess I should just do continue there. Ah, okay, we got something. And there we go. There we go. Got my answer. All right, so this is how it should have been for part 1. This way. This is the correct way to do it. Yeah. And then in theory, part 2 brute force is the same way. And there we go. Okay. Well, yeah, still doesn't fix the part 2 of me not knowing how to do a cycle. But, yeah. I don't know if there's a way to make this more efficient. Try to like look. I don't think this is. Yeah, it's about fast I can make it. Maybe there's a fast. Maybe there's something else I can do to make it a little faster, but I don't know it off the top of my head. But and like I said, yeah, you just get to the point where you gotta find the cycle part 2. So there we go. All right, that's the real end for day 20. See you guys.